Alright guys, today's video is about looking at a scale model, a scale drawing, and calculating distances on that scale drawing. I'm pretty sure you've done something like this before in a social studies class. Social studies classes spend a lot of time looking at maps or diagrams, and I'm sure that your social studies teachers at some point in your education have talked about the scale of the map. So we're going to look at how you actually use that scale mathematically on maps, diagrams, blueprints, etc. You should be on page 68 in your notebooks, and the date is November 19th, 2013. Make sure you are putting those things and keeping your notebook nice and organized. Notebook check comes very quick. There's a few vocabulary words that we need to get taken care of before we jump right into the math part of this. And some of those words are scale drawing. A scale drawing is simply a diagram of an object in which the dimensions, distances I think might be a word that's more familiar to, so that the distances or dimensions are in proportion to the actual dimensions of the object, a blueprint, a map, etc. The scale, we talked about this in the video from last night, the scale tells us how the dimensions or the distances or the sizes of the drawing and the actual dimensions are related. So a lot of times on a map you'll see something like this, 1 inch, and then you'll see a colon, and then you'll see 12 feet. Well, you might recognize this colon as something we use in math when we are writing ratios. So for example, we could write the ratio 3 to 4, which is the same as 3 over 4. Okay, so it's just another way to write a ratio, and this is how it's usually written on a map or a diagram. And it means that every 1 inch that's on the actual diagram is actually 12 feet in real life. 1 inch is to 12 feet. Okay? Take a minute to write all that down, including the little notes that I put. And when you're ready, go ahead and continue listening, and we'll move on. On this same page, there are some steps that we need you to write down for how you're actually going to approach these problems. So the first thing we're going to have to do is, if a picture isn't given, if a picture is not there, you need to draw a picture. This is probably the most frequently skipped steps in this process, and it's something that people just always do wrong. You've got to draw a picture, okay? After that, you're going to write a proportion. And in class today, we talked about the fact that we had to keep the same things on the same level. So when we made a proportion, we had a fraction equals another fraction. And I told you to make a little note over on the side, like maybe the top was the measurements from your big shape, and the bottom could be measurements from your small shape, and that helps you keep things lined up. That's what I mean by keep similar things on the same level. Otherwise, you're setting up your proportion all wrong, and it's going to cause a lot of problems for you. Step 3 is to cross multiply so that we have our cross products. When we cross multiply, we set the cross products equal to each other. So this would be the first cross product, and this would be the second cross product. Some people are still trying to set it up as a fraction, cross product over cross product. That is not correct. Fourth step in this is to solve that cross product equation with algebra, and then, especially in these real world problems, you need to check to see if it makes sense. So if you end up with a calculation that tells you in the real world a person is 200 feet tall, you've made an error somewhere. That's what's nice about these real problems. You can kind of see if it's realistic. Let's go ahead and make sure you're putting all these little notes, guys. I see a lot of people not doing that. Those are important. Let's go on to some examples. You don't have to try and draw this picture, but I do want you to write this problem down. It should be on the top of page 69. It's November 19th, 2013. And for this drawing, we have, from the map's scale, 1 centimeter represents 65 kilometers. And you can see that here. That's where the scale is shown on this map. On the map, the distance between China and New Sweden is 4.5 centimeters. And then it wants us to find out what the actual distance is. Now, we don't have marked on this map the distance from China to New Sweden, so I'm going to go ahead and do that. That's part of my step one, drawing a picture. So I have some idea of what I'm working with. It then tells me that this distance is 4.5 centimeters on my drawing. And it wants me to find out how big my the actual distance is, so how many kilometers it is. We know when we're having proportions that we're going to have one fraction equals another fraction. That's our standard setup. We just have to figure out what's what. So just like today in class, we labeled one level one thing and the bottom another thing. Let's go ahead and label the tops of our fractions. We'll say that's on the map. Okay, so those will all be map measurements. And on the bottom, let's call them the real measurements. Okay, so the measurements that you would actually drive in a car. We have right here given to us the first ratio that we need, the first fraction we need. 1 centimeter is to 65 kilometers. Well, the map measurement here, the one that should go on top, is my 1 centimeter. You need to be putting these kind of labels in, the units, when you're solving real world problems, when you're solving proportions. It makes your life so much easier. And then down at the bottom, we'll have 65 kilometers. And then we have to figure out how to set up this fraction over here. We know, based on the information given to us in the problem, that this distance is actually 4.5 centimeters. Sorry, on the map, it's 4.5 centimeters. So we have to ask ourselves, would that go on top or would that go on bottom? Well, since our top units are the map units, it would go on top. So we would have 4.5 centimeters there. And then what on earth do we put here at the bottom? We just put a variable, guys. Put an x. Next step that we have to do in this kind of problem is to take our cross products by multiplying. 1 centimeter times x is just 1x, or plain old 1. You don't really need the, plain old x. You don't really need the 1. And then 65 times 4.5, which is, hang on, 292.5 kilometers. Now, you have this little 1 out here in front, and I know that some of you guys are going to want to get rid of that by doing the balance and dividing by 1, giving you x equals 292.5 kilometers. But I want you to notice that that just gives us the same answer we have right here. If the coefficient of our x value is just 1, then we've already found our answer. Okay, guys? Let's look at another example. This one doesn't have a picture, so we're going to have to draw a picture for this situation. It says that John stands next to a tree that is casting a 15-foot shadow. John is 6 feet tall and has a shadow that is 2 feet long. We want to know how tall is the tree. We're going to draw a lovely picture, and I don't care if you're an artist, I don't care how pretty it looks, just draw me a little bit of a picture. If this is our tree, lovely, and it has a shadow that is 15 feet long, we'll say that's the shadow. And then we have John here, who is 6 feet tall, and he casts a shadow that is 2 feet long. We want to know how tall the tree actually is. That's what we don't know. That's supposed to be a question mark, sorry. So now we have to go to actually setting up the proportion. It's going to be a fraction equals a fraction. Put your little labels on so you know what's what. Let's say, oh, I don't know, let's call the top the tree and the bottom John. The tree is some height tall. We don't know how much. It's x. And it casts a shadow that is 15 feet long. So there's our 15-foot shadow. I'm going to put an S there so we know it's the shadow. And then we have, oh, I made a mistake. I'm sorry, guys. That number, the shadow length, should have been over here because our top level, remember, is for the tree. So that's a 15-foot shadow. I apologize. Hopefully I didn't confuse you too much. And then when we go to John, John is 6 feet tall. So that's going to go in this height section because the tree is X feet high, and John has a shadow of 2 foot. Now we are going to cross multiply, giving us x times 2 is 2x, 6 times 15 equals 90. We use algebra to solve this and end up with x equals 45 feet. That tells us the height of the tree. Here is where you ask yourself, does that actually make sense? Do you think a tree would be about 45 feet tall? Well, yeah, that does. That makes a lot of sense. Okay, your reflection question today, guys. The scale used to build the scale models of 4 airplanes is 1 to 72. 1 centimeter to 72 centimeters, I think. We'll just call it centimeters. It might be feet, but we'll say centimeters. Estimate the actual wingspan of the airplane given the wingspan of the model. So the Kitty Hawk model has a wingspan of 17.1 centimeters, and you need to find out what the actual wingspan of that airplane was. You know what? It can't be centimeters. We'll call that feet. Okay? So I look forward to seeing your responses. Have a good one. Bye-bye.